In this problem, we're given an exponential equation and we are to solve it for t. The first thing to realize when doing this is that before I use any technique involving a logarithm, I first must isolate this factor here, 1.26 raised to the t. In fact, since I'm trying to isolate this, it would be wise to think of that as a single entity, meaning that to solve this equation, you would do the same thing as if you were to solve the linear equation that looks like this. So imagine this factor, 1.26 to the t, being thought as a single entity like the letter x. This would look like a linear equation, and it would be more obvious that to solve this, we are to do nothing more than take anything being added and simply subtract it over. Anything being multiplied, like the 40, would be divided. I'll start by simply subtracting 3. Because the 40 is being multiplied, I will divide both sides by 40. Since 40 divided by 40 is simply 1, the left-hand side will be simply 1.26 raised to the t. Since I'm trying to avoid any rounding, I'm going to leave the right-hand side as an exact answer. I will not estimate my answer using a calculator to the very end. At this point, to solve for t, I'm going to rewrite this equation using a logarithm. This equation in exponential form can be written in log form, where as a subscript down here on the log, we write the base 1.26. The 1.26 is raised to the t power. I will put that on the other side of the equal sign because in log form, this is the base, 1.26. It's raised to the t power, and the result that you get by doing that would be written right here as the input into the log function, which is this fraction. Now I've isolated t. This is the exact answer to the equation. If you now wanted to approximate the answer, you would type it in exactly as shown, unless your calculator does not have the ability to write the subscript. If you do not have the ability to write the subscript on the logarithm, you would have to use the change of base formula, which basically says that I can change any base into any other base that I like, and since I'm going to use a calculator that has a base 10 logarithm shown here and a base e logarithm, the natural log, I'm either going to change this into a base 10 or base e. So you have a choice. You could either write this as a base 10 logarithm, log, of this quantity divided by the log of the base, so the base of this logarithm becomes the input into the logarithm in the denominator. So let me show you what this would look like on the calculator. I would type log of this quantity divided by the log of the quantity 1.26. Notice my use of parentheses in the first logarithm, that entire quotient here is the input into the logarithm. Notice that you could have used the natural log instead. I've typed the exact same answer in, but using a natural log rather than a common logarithm. Notice I get the same answer. I'll round my answer to 3 decimal places, so I get 16.583. Notice my use of the approximate symbol here as opposed to the equal symbol. I did this on purpose because at this point, this is an exact answer. I did not use a calculator to approximate the solution until this step, going from here to there. Rather than stopping here, you may want to plug your solution back into the original equation to see if it works. Let me show you how to do that without using the rounded version of the equation. In your calculator, the last thing that you entered is stored in the previous answer feature of the calculator. I'm going to type out the left-hand side of my equation, 3 plus 40, 1.26 raised to the power of t, but rather than using a variable, I'm going to use the previous answer feature on my calculator. Press the second key, then press the negative key to get A and S to show up on your screen. It's going to plug the last answer in to that exponent now, and when I press enter, notice I get exactly 1,850, meaning my solution to the equation is correct.